Hello, good morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Ionic Equilibrium, and in this session we are going to learn about calculation of pH value for a mixture of solutions. Right? Let's start the session. So what is given here? If two strong acids are mixed, when two strong acids are mixed, then H plus ion concentration of that mixture, okay, the H plus ion concentration of that mixture, because two are strong acids, they may be same or different, but two acids must be strong. Two acids must be strong. Then H plus ion concentration of this mixture of solutions is given by N1 V1 plus N2 V2 by V1 plus V2. Okay, so let us see two acids. So there is an acid here. Okay, there is an acid. For example, let me take it as HCl, whose volume is equal to V1, whose normality is equal to N. Sir, if instead of normality, if molarity is given, then what to do, sir? We have to convert it into normality. We know how to convert it into normality. What is the formula behind that? We know that normality is equal to molarity into N factor. Normality is equal to molarity into N factor. By using this, if molarity is given, it is better to convert it to normality and solve the problem. Okay. So now there is another HCl solution. There is what? Another HCl. Or you can also take H2SO4, HNO3, whatever it is. So HCl, whose volume is equal to V2, whose normality is equal to N2. V1, V2 can be same, N1, N2 can be same, different. It doesn't matter. Now what you are doing? You are mixing these two. What you are doing? You are mixing these two solutions. That means you have poured this HCl into this and HCl also this into this. Okay. And we know a formula. What is that formula? Normality is equal to number of equivalents by volume in liters. Okay. Normality is equal to number of equivalents by volume in liters. And from this I can write number of equivalents is equal to normality into volume expressed in liters. This is one formula. Okay. There is another formula called as number of equivalents. What is that? Number of equivalents is equal to given weight by equivalent weight. Another formula, number of NEQ means number of equivalents. What is that? Number of equivalents. Number of equivalents is given by another formula. What is that? Weight by equivalent weight. Right? Here, when you are mixing two solutions, there is no reaction happening between them. When there is no reaction happening between them, the number of equivalents just get added. Okay, so let us take this solution as 1, this solution as 2. What is that? Let us take this solution as 1 and this solution as 2. That is the reason why we have mentioned V2, N2, V1, N1. What is the number of equivalents of 1 is equal to N1 into V1. Now only we have seen N into V. What is the number of equivalents of this solution? Second solution is equal to N2 into V2. Now you have added these two solutions, two HCl solutions. So I write number of equivalents of a ternary mixture. The number of equivalents of mix, you have mixed it, then that will be equal to number of equivalents of one solution plus number of equivalents of solution 2. Is there any change in the number of equivalents? No, because there is no reaction happening. When there is no reaction happening, just they get added up. Okay. Now here let us take number of equivalents is equal to, here formula we have written, what is that? N mix into V mix. Mix means we have mixture. Okay. So number of equivalents one means N1 into V1 plus N2 into V2. The normality of the mix can be written as N1 V1 plus N2 V2 by mixed volume will be equal to V1 plus V2. Just they get added up. Volume is added up. If it is 50 ml and if it is a second solution is 100 ml, when you add up 50 plus 100, 150 ml, it becomes 150 ml, right? So I can write it as V1 plus V2. So this is the formula what you got, you see? Formula what we got. Okay. And already we have studied that for strong acid, normality of solution, strong acidic solution is equal to H plus ion concentration. It is equal to H plus ion concentration. Okay, so now what did we get here? Normality. Instead of writing this normality, both are acids, no? Simply I can write H plus ion concentration. H plus ion concentration is equal to N1 V1 plus N2 V2 by V1 plus V2. So this is the formula. Understood? So let us see it in the form of a question. So here is a question given. In this question, if you see carefully, here is a HCl solution. What is that? HCl solution. HCl whose volume is equal to 100 ml, whose molarity for HCl I can write molar n factor is equal to, what is the n factor for HCl? 1, because only one replaceable hydrogen is present. HCl dissociates to form what? H plus and Cl minus. So for HCl especially, for HCl molarity is equal to normality. So here it is given molarity. So directly I can write normality. So 0.15 normal. Okay. Another HCl solution is given, right? Another HCl solution is given. Other one is also HCl solution where its volume is equal to again 100 ml. Its normality is equal to how much? 0.05. 0.0. So now it is mixed. Mixing means you are mixing here. You are mixing. So both this is mixed into this and this is mixed into this. So total volume V mix will be equal to V1 plus V2. Let me take it as V1. It will be taken as okay, N1 is equal to V2 N2, right? V1 plus V2, that is equal to, what do you get? 100 plus 100, 200 ml. So final normality is nothing but H plus. So H plus formula, direct formula, let us use. What is that formula? N1 V1 plus N2 V2 by V1 plus V2. N1 is how much? 0.15 into 100 ml. 100 ml plus N2 is equal to how much? 0.05 into 100 ml. Okay. So what will be the units here? Here the units will be normality into ml, right? V1 plus V2 is 200 ml. So ml gets cancelled. Then what do you get? 0.15 into 100 gives you what? 15 plus 0.05 into 100 gives you 5 by 200 normal. That is equal to 20 by 200 normal. That is equal to 1 by 10 normal. That is equal to 0.1 normal. So what did we get? We got a H plus ion concentration, but asked is pH. What is the pH of the resulting solution? And we know the formula. What formula do we know? pH is equal to minus log H plus ion. That is equal to minus log. How much did we get? H plus ion concentration? 10 power minus 1. So minus of minus 1 log 10. That is equal to plus 1. Did we get the answer? Did we get the answer? Yes, we got the answer. Did you understand each and every step, each and every single point it is mentioned here? If you follow it carefully, you can understand it very well. Understood? Right? Let us go with the next one. So now we are speaking about in the cases of two strong bases. Two strong bases. Right? The same similar pattern we will be finding. So let us take a base, strong base. Okay. Let us take a strong base here. Let me take it as NaOH. NaOH. So let it be sample 1. That means solution 1. And another is also same. Let me take NaOH. Or if I can take KOH, I can take barium hydroxide. I can take calcium hydroxide. All these are considered to be strong bases. Okay. So second solution. Its volume is equal to V1. Its normality is equal to N1. Its volume is equal to V2. Its normality is equal to N2. Now what you are doing? You are mixing these two. What you are doing? You are mixing these two. On mixing these two, what happens? Simply their number of equivalents gets added up. Their number of equivalents get added up. You are mixing these two. Okay. So what will be this? What will be the normality of this resulting solution? If I take here number of equivalents of mix. What is the number of equivalents of this solution? Number of equivalents 2 is equal to, what is that? N2 into V2. Here number of equivalents 1 will be equal to N1 into V1. Then number of equivalents of the mixture means just see, both solutions are basic solutions. Simply their number of equivalents get added up. Their number of equivalents gets just added up. So number of equivalents of the mixture will be equal to what? Number of equivalents 1 plus number of equivalents 2. That is equal to N1 V1 plus N2 V2. Here Number of equivalents, we already studied that the formula is normality of the mix. Okay, mix into volume of the mix. So normality of this mix will be equal to N1V1 plus N2V2 by volume of the mix means both volumes get added up. That means what will you write? V1 plus V2. So already we have studied a point that for a strong base, okay, the normality of the base, okay, normality of the base is equal to OH minus N. So what did you find? What you are finding here? You are finding normality of the strong bases. So both are strong. Then directly I can write it as OH minus N concentration. OH minus N concentration is equal to formula N1 V1 plus N2 V2 by V1 plus V2. Understood? Why we are taking OH minus? Because these two are bases. They produce OH minus. On dissolving in water, what do they release? They release OH minus. Okay. So let us solve a problem on this. What is given here? One solution is what? NaOH solution, strong base, whose volume is equal to, let me take it as 100 ml, whose normality N1 is equal to 0.15 N. NaOH dissociates to form Na plus and OH minus. It is releasing one OH minus. So what is its N factor? Its N factor is equal to 1. So in the case of NaOH, molarity will be equal to what? Normality. What is that? Molarity will be equal to normality. So let us take the sample as 1. In the next sample, let us take here what is given. Yes, given KOH solution. Let us take this sample as 2. Solution 2. So whose volume is equal to 100 ml again. Whose normality, let me take this N2. Whose normality is equal to 10 power 0.05 normal, because molarity is equal to normality. Molarity is equal to normality. Because N factor of KOH is also 1. KOH dissociates to form K plus plus OH minus, whose N factor is equal to how much? 1. When N factor is equal to 1, then molarity becomes equal to normality. Here it is given molarity. We have converted into normality. Because always it is better to convert into normality and then solve the problem. Because for all the acids and bases, N factor may not be equal to 1. If N factor is not equal to 1, then it changes. Okay, so compulsorily we have to convert molarity into normality so that we get the correct answer. So now these two are what is done? These two are mixed. What is done? These two are mixed. So NaOH is mixed into this, KOH is mixed into this. Then now only we have seen formula, final normality. Final normality of the mix is equal to N1V1 plus N2V2 by V1 plus V2, which is nothing but the OH minus ion concentration. For a strong base, normality of that strong basic solution is equal to OH minus. I can take directly it as OH minus ion concentration. Normality 1, 0.15 normal into what is that 100 ml plus N2 0.05 N into again 100 ml by 100 ml plus 100 ml. Then what do you get? OH minus ion concentration is equal to, this will be 15 plus 5 normality into ml units by 200 ml. ml gets cancelled. Then what you get? 20 by 200, that is equal to 0.1 normal. So what did we have now? We are having OH minus ion concentration. But the question, in the question it is asked about pH. What is asked? pH is asked. Now we can calculate POH. POH is equal to minus log OH minus ion concentration, that is equal to minus log 10 power minus 1, that is equal to what? 1. So what did we get? POH1. And we know that pH plus POH is equal to 14. pH is equal to 14 minus POH, that is equal to 14 minus 1, that is equal to 13. So the answer is what? 13. Because the question asked is what is pH of the resulting solution? What is the pH of the resulting solution? 13. Understood? Understood? Right. Let us see the next question, next part. If excess of strong acid is added to limited quantity of strong base, okay, we know neutralization reaction. What is that? Neutralization reaction. Okay. What is neutralization reaction? Acid reacting with base to give salt and water, according to Arrhenius. For example, HCl reacts with NaOH to give you NaCl plus H2O. Okay. So from this reaction, I can say that one equivalent of acid completely reacts with one equivalent of a base. So always they react in 1:1 ratio of their equivalents. One equivalent of an acid always react with one equivalent of a base. One equivalent of a base. One equivalent of acid always react with one equivalent of a base. Okay. Now, for example, in this solution, we have mixed acid and base. What acid and bases we have mixed? One is HCl, another is NaOH. If HCl present is two equivalents and if NaOH present is in two equivalents, what will be the nature of the solution? What will be the nature of the solution? It will be neutral. Why? Two equivalents of acid completely react with the two equivalents of a base to form salt and water. There is no acid remained, there is no base remained. There is no acid remained and there is no base remained. Right? So now the solution becomes neutral. If it, let us see another mixture of acid and base. For example, if I am having HCl, two equivalents, NaOH, one equivalent. Now, what will be the nature of the solution? It will be acidic. Why it is acidic? Because HCl is two equivalents, NaOH is one equivalent. HCl plus NaOH gives NaCl plus H2O. At time t is equal to 0, you have two equivalents, you have one equivalent. After reaction, what happens? After reaction, 2 minus 1 equivalent, 1 minus 1 equivalents. See, one equivalent of base always react with one equivalent of acid. So, how many equivalents of HCl is remaining? One equivalent of HCl is remaining. So, among these two equivalents of HCl, one equivalent of HCl completely reacts with one equivalent of NaOH. One is completed, the remaining one remains. This one equivalent remains in the solution. What is remaining? HCl equivalent is remaining. So, it will be acidic. What is that? It will be acidic. Understood? So, for example, let us take another solution. Here, we are taking another solution. HCl is one equivalent. NaOH is two equivalents. Now, what will be the nature of the resulting mixture? The nature of the solution will be what? Basic. Why it is basic? Because one equivalent of HCl completely reacts with one equivalent of NaOH. Who is remaining in the solution? One equivalent of NaOH is remaining. Base is remaining. As base is remaining, the nature of the resulting solution will be basic. So let us see, HCl plus NaOH gives rise to, right? What is that term? NaCl plus H2O. Time t is equal to 0. How many? One equivalent. Here it is two equivalents. Then after reaction, what is completed? One equivalent is completed. So 1 minus 1 equivalent. Here 2 minus 1 equivalents. That is equal to here 0. Whereas here, how many equivalents are remained? Here 1 equivalent of who is remained? Base is remained. Who is remained? Base is remained. As base is remained, then it will be basic. The simple logic is that, okay, if excess of strong acid, excess here, this is the condition. Where is that condition? Here is the condition. This is the condition. Here is the condition. Here is the condition. Excess, two equivalents. When excess of strong acid is added to limited quantity of strong base, NaOH is strong base, limited quantity, then the remaining solution will be acidic. The final normality is H plus. Okay, so let us see that. Here you are having an acid. You are having an acid. This is acid, whose normality is equal to Na, whose volume is equal to Va. Here is a base. What is that? Here is a base. Base whose normality is equal to Nb, whose volume is equal to Nb. Okay. Now you have mixed these two. You have mixed these two. Here the condition is NaVa is greater than NbVb. Excess of what? Strong acid. So this is acid. This belongs to acid. That means number of equivalents of acid is greater than number of equivalents of base. Okay. Now as this is more in number, now only we have seen this. You are cancelling, you are subtracting NaOH equivalents from HCl. Then number of equivalents of mixture, before also we have seen, this will be equal to NaVa minus NbVb by Va plus Vb. Okay. So what will be this? This will be normality. What is that? Normality of the mixture. So what is remaining in the solution? Acid. What is remaining? One equivalent of acid is remaining in the solution. So I can write that H plus, because acid substance which releases H plus. H plus is equal to NaVa minus NbVb by Va plus Vb. Okay, so let us solve a problem from this by using this. NaOH, H2SO4 are mixed. Okay, NaOH and H2SO4 are mixed. So this is NaOH. This is what? H2SO4. Number of equivalents is equal to, for H2SO4, N factor is equal to how much? N factor is equal to 2. Okay. Here given molarity, 0.1 molar is equal to 2 into 0.1, that is normal, which is equal to 0.2 normal. 0.2 normal. Here NaOH given normality 0.1. So what is this? This is NaOH and this is what? H2SO4. 0.1 normal, volume is equal to 50 ml. Here volume given as 50 ml. Okay. So now let me take it as H2SO4 here. Let me take it as V2 N2 here, V1 N1. Okay, V1. So or let me take this as base. This is what? Acid. This is acid. Okay. Normality of the acid is how much? Normality of the acid is equal to what? 0.2 N. NbVb is equal to how much? 0.1 into 50, that is equal to 5. Okay, NaVa is equal to how much? Na is 0.2 into volume is equal to 50, that is equal to 10. Okay, so from the formula what you can write? H plus ion concentration is equal to, whether NaVa is greater or NbVb is greater, NaVa is greater. So I can write it as 10 minus 5 by, okay. So what will be the units? Units will be normality into ml. Okay. By 50 plus 50 will be equal to how much? 100 ml. ml gets cancelled. Then what you get? 10 minus 5 will be 5. 5 by 100, that is equal to 5 into 10 power minus 2 normal. So what did you get here? We got H plus ion concentration. Then what will be pH? pH is equal to minus log, what is that? Minus, pH is equal to minus log H plus ion concentration. That is equal to minus log, but 5 into 10 power minus 2. that is equal to minus log 5 log a plus b plus log 10 power minus 2, that is equal to overly 2 minus log 5, that is equal to 2 minus 0.6990, that is equal to 1.3010. So that will be the answer. As H2SO4 is more than NaOH, the resulting pH will be less than 7. You are finding 1.3010. So what are mixed here? What are mixed here? NaOH and H2SO4 are mixed. When NaOH and H2SO4 are mixed, there will be acid-base reaction. If both are same, then it results in neutral solution. If acid number of equivalents are greater than basic number of equivalents, like this condition here, this is the condition, then it results in acidic solution. If it is acidic solution, the pH of the solution will be less than 7. The pH of the solution will be less than 7. So now the pH is less than 7, which is equal to 1.3010. Okay, 1.3010. Understood? Then let us go with the next question. Equal volumes of 0.1 m potassium hydroxide. So let us take a base potassium hydroxide. Volume of the base is equal to V. Normality of the base is equal to, for who n factor is equal to 1, because only one OH minus is present. Only one OH minus is present. So number of normality of the base is equal to how much? 0.1 normal. Because as n factor is equal to 1, molarity will be equal to normality. Next, another one taken, H2SO4, whose n factor is equal to 2. Whose n factor is equal to 2. Volume of the acid is also V. Because equal volumes, they mentioned here it has equal volumes. So number of normality of acid is equal to, okay, molarity of the acid into n factor. That is equal to molarity given how much? 0.1 into n factor 2. That is equal to 0.2 normal. So NaVa is equal to how much? V into 0.2 n. That is equal to 0.2 n into V. Here NbVb, that is equal to how much? What? 0.1 n into volume. So which is greater? Which you are finding it as greater? 0.1 n into V is greater, or 0.2 n into V is greater? 0.2 n into V is greater. So acid number of equivalents are greater than base number of equivalents. Acid number of equivalents are greater than base number of equivalents. As acid number of equivalents are greater than base number of equivalents, then the resulting solution will be acidic. Resulting solution will be acidic. If resulting solution is acidic, then pH of the solution will be less than 7. pH of the solution will be what? Less than 7. So the pH of the resulting solution will be what? Less than 7. This is the answer. Okay, that's the answer. Here also you see the nature of the resulting mixture. In the question number 1, you are seeing the nature of the resulting solution will be what? pH is equal to 1. No, it will be acidic. Are you finding this? Okay. Here also nature of the solution is asked. Here also the nature of the pH of the resulting solution is asked. So if the solution is acidic, the mixture is acidic, automatically the pH will be less than 7. Okay, so formula you have to remember. What is that formula? If number of equivalents of acid are greater than base, then the resulting mixture H plus ion concentration is given by NaVa minus NbVb by Va plus Vb. Okay. Next, let us see. Before we have seen that number of equivalents of acid are greater than base. Here, number of equivalents of base are greater than acid. When in the mixture of acid and base, if number of equivalents of base is greater than number of equivalents of acid, then this formula arises. So let us take here we are taking acid. What is this? Acid. Let the number of moles of acid be Na. Number of volume of the acid be be Va. Now we have taken a base. Okay. What is this? Base. Number of equivalents of base be Nb. Volume of the base be Vb. Now, what did you do? You have mixed these two. So, number of equivalents of the mix will be equal to. Condition here it is. What is the condition? The condition is a number of equivalents of base greater than number of equivalents of acid. That means NbVb is greater than NaVa. What is N? Normality. Then what you can write? Number of equivalents of base minus number of equivalents of acid. So number of equivalents of the mix means normality of the mix into volume of the mix is equal to, you have mixed these two solution. So NbVb minus NaVa. So normality of the mix can be written as NbVb minus NaVa by volume of the mix means two volumes you have mixed. Simply I can write Va plus Vb. In the case of strong bases, normality of, before we have spoken this, normality of strong base is equal to its OH minus ion concentration. Will be equal to what? Its OH minus ion concentration. So simply I can write it as OH minus ion concentration of this mixture is equal to NbVb minus NaVa by Va plus Vb. Okay. Now let us solve a problem on this formula. So what is given? HCl. Another one is given NaOH. For both n factor is equal to what? Let us write NaOH. Here n factor is equal to 1. Here also n factor is equal to 1. N factor is equal to what? 1. So molarity will be equal to normality. Here Normality is equal to how much given? HCl 0.1. Actual molarity given, molarity 0.1 into 1 gives you 0.1. So 0.1 normal Na. Volume of the acid is given 50 liters. Here normality of the base given 0.2 N, because molarity is equal to normality. Directly I took normal. Okay. So then VB is equal to how much given? Here also it is given 50 liters. 50 liters. So now NBVB is equal to 0.2 into 50. That is equal to 10 normal into liter. Okay. So NaVA is equal to 0.1 into 50, that is equal to 5 normal into liters. So which is greater? Which is greater? NaB. Now you are finding that NBVB is greater than NaVA. So what is that? NBVB is greater than NaVA. Then formula OH minus ion concentration on mixing. Are these two mixed? Yes, these two are mixed. 50 liters of 0.1 m HCl is thoroughly mixed with 50 liters of 0.2 m NaOH. What is the pOH of the resulting solution? OH minus ion concentration. Now only we have derived a formula. What is that? NBVB minus NaVA by VA plus VB. That is equal to NBVB how much? 10 normal into liters plus NaVA is equal to NaVA is equal to how much? Minus 5. What do you get? Normal into liter by VA plus VB. VA, what is this? VA plus VB is equal to 50 plus 50 liters. Okay. So that is equal to 5 by 100. That is equal to 5 into 10 power minus 2. So what did we get? OH minus ion concentration. What did we get? OH minus ion concentration. And we know the formula POH is equal to minus log OH minus ion concentration. Then that is equal to minus log 5 into 10 power minus 2. That is equal to minus log 5 plus log 10 power minus 2. That is equal to log 5 is equal to 0.6990 plus minus 2 log 10 base 10. That is equal to minus 0.6990 plus minus 2. That is equal to 2 minus 0.6990. That is equal to 1.30. What did we get here? We got POH. We got a POH. So question asked is POH. Question asked is POH. If you are asked pH, mostly they ask pH. So then if I ask pH, now let pH is equal to what? 14 minus POH. 14 minus POH. That is equal to 14 minus 1.3010. Then that is equal to 12.6990. Okay, 12.6990. So pH greater than 7 represents that it is basic solution. pH greater than 7 represents that it is a basic solution, right? So here as base number of equivalents are greater than acid number of equivalents, the resulting solution will be basic. The resulting solution has more OH minus ions. As the OH minus ions are are remaining in the solution, it results into basic solution, and that can also be understood by here as pH. Finally we got it as 12.6990. What did you get? pH of the solution is equal to 12.6990, which is greater than 7. So pH greater than 7 represents that it is a basic solution. Okay, so that is with this calculating the pH, calculating pH of mixture of solutions. Hope so you understood very well. Once again I am saying that it is a video. How many times you want, you can watch it, you can rewind it, you can forward it. So if you don't understand, you rewind it again, you follow each and every point. I have noticed you each and every point, each and every step. This type of questions are asked in the competitive examinations like JEE and NEET. Right? Do follow the classes and learn the subject, right? Thank you. Let us meet in the next class with a new topic.